Catalina is going to talk to us about applications of machine learning in the oil and gas industry. I've been on panels with Catalina. I've heard her speak before, extremely knowledgeable. I'm looking forward to hearing what you have to say again, Catalina. Let's give it up for Catalina.
Hello, hello. Testing. All right. Good morning. Okay, not so bad. I want to properly introduce myself in about 2 minutes, but I wanted to start this session with this picture. Did you know this is a prediction? You don't have to have an answer. Did you know this is machine learning outcome? I provided an image, I added some text, I changed it, I saw it, cool, let's prepare for this session. I decided to provide some text to the Midjourney bot, and I say, hey, let's see how well we'll look in 2030. And it provided that picture on the left. And I say, well, why not? Let's have the other chat interact with that. So I asked ChatGPT to provide more details into how a well from 2030 will look like. And he gave me that picture on the right with all the details that ChatGPT gave me in the other paragraph. Then I did the same with a wind turbine. And it's like, okay, we are in the everyday AI chapter already, okay? And that's the beginning of this session. So welcome to this session. My name is Catalina Herrera. I am an electronic engineer by trade, but my first data science job was at the Alternative Energy Institute at West Texas A&M University. I was collecting data from the wind turbines all over Texas, characterizing that data to see how the wind developers were going to use the direction of the wind, the speed of the wind to maximize production. My first professional data science job was at Texas Instruments. I was a yield engineer for 6 years, and my job was to process that data coming from all over, on-prem, in the cloud, a little bit here, a little bit there, 10,000 steps that takes for a semiconductor to actually become a microprocessor that you can put in your computer. My job was to detect the failing microprocessors as soon as in the process as possible to save more money. Aren't we all trying to optimize production? One way or another. All right. So today, we're going to talk about breaking these digitalization barriers. And we all know, we have been talking about machine learning for a day here, and we have seen all these use cases, phenomenal use cases out there. And we all know that this is not new at all. In fact, a lot of history here, a lot of brilliant minds collaborating with all those math stacks, probability, and everything that we use as foundation. Phenomenal increase on technology in the last decades, where we have more compute power, we have GPUs, we have everything else that is available out there. How much money you paid for your first USB? What was the physical space? What was the capacity? How much money you pay today? Same physical space, capacity. Everybody is seeing that exponential growth, right? All right. So basically, we have been, can you push play over there, team, back? There is a video. Thank you. So historically, we have been trying to imitate what we do as humans for decades. How do we talk to each other? How we interact with bots? How do we see? What is computer vision, sensors, telemetry? What if scenarios? We have been doing NLP techniques for years. We have been working on this for years. This is absolutely not new at all. This is a trajectory. We have been working on it. But we have been landing slowly into what is it that we are trying to achieve. And we know that we are targeting optimization. This is an info brief that Dataiku produced in February 2023. And if you see the top use cases that AI is targeting around this room and also with your peers outside, is actually quite interesting. Optimization, optimization, improvement, improvement, improvement. So today I work for Dataiku. I am a principal engineer at Dataiku. And Dataiku is what I say is the everyday AI platform. But when I say that, I also have to mention that as my job, my role, I talk to many of you weekly. In fact, I have met many of you in your career before you were what you are today. Like we have been going together in this journey from the analytics side, from the BI side, for all that. And our goals now more than ever, that we know this is very tangible, and I'm sharing the McKinsey metrics from 2021, when we say efficiencies by 30% or more, increasing efficiencies by 30% or more, increasing revenues by 5%, 10%. We all know that that is achievable. In fact, we are here sharing very cool machine learning models and use cases. However, by the way, every single image that I created in this was using AI. Why not? So every single organization is still struggling. We're going to talk about those barriers. What are those barriers? So if you think about how do you connect your people, your technology, and your processes, and how that is still providing a lot of gaps in between. So let's think about the people and all those data science that we have in the room with phenomenal machine learning models out there. Think how many are using your model outside your team or 3 or 4? Are you really sharing that machine learning outside your organization where you are connecting what you are building outside your desktop? So yes, you know Python, you can use a couple of libraries, you can use a couple of packages, but is that being utilized by the extended team in the most optimal way? Also technology, and everybody here can be familiar with this. We have been changing that technology for years. We have been changing pockets of technology. Now we have better compute engines. Now we have GPUs. Now we have a different ecosystem. But you will always have that data source that is going to come from your on-prem. And you're always going to have that diverse ecosystem that is going to end up feeding the data that you need for your use cases when you are targeting machine learning. So bear with me. I'm going to reproduce what an analytics process looks like behind the scenes. And we can think about those upstream use cases, machine learning we have seen. We can think about anomaly detection on the telemetry of the sensors coming from the factories and the refineries. Or we can think about energy trading. Let's talk about energy trading. Energy trading, example. So we have a group of people that is asking questions to this data. The number one thing that they need to do is to interact most likely with third-party information, combine that data, look at that trend, see if they can become predictive. Why not to see a time series prediction out there and see if you're going to predict fraud, for example. That's actually a very good idea. As I'm going to point out here, every single analytics use case, call it anomaly detection, predictive maintenance, computer vision, you call it, has to start with the business understanding first. Period. Your use case has to be number one. Now, what happens when you say, okay, this is my use case, therefore, I'm going to feed it. So I have a KPI, I have variables on that KPI, that's my business use case. And when I think, where is the data coming from? Well, half of it is structure, half of it is unstructured. We have PDFs all over. We have these on-prem data sources here. We also have a cloud strategy. We're going to be working with clouds. We have a very, very diverse ecosystem. Then what is going to happen? You're going to have to prepare that thing. Who is going to be consuming this? How? Most likely, you're going to create a product. I will call it a data product. And we can think about a data product as the machine learning model or the dashboard that is being served to a different group of people, or the data table as a result of joining 3, 4 data sets and sharing a data table with the rest of the team. But at the end, the fact is that you are building a solution that you will like for it to be consumed by your company. Remember, this is a use case value. You are targeting a KPI. You are targeting a business use case. And you would like to involve that people into the solution building, as in what is it that I am delivering? How is my coworker gonna consume my super cool machine learning model that I just put together and I feel very proud because it's super precise? But then what? What are you gonna do with that? Okay, cool. So the next step will be, how do we evaluate that what we are producing is accurate and it's aligned with our own standards? And that's where things start getting a little complicated, because none of this has even gone to production yet. So we're still on the first half of what I call the framework, where behind the scenes, you have a very diverse group of people that needs to interact to each other, that needs to communicate with each other, and that perhaps has a very different background in terms of skills. You love Python, you love R, you are very good with SQL, you don't care, but you care about the results of your machine learning model. So, where are the barriers coming from? Those barriers are coming from that framework where you have a group of people that is not talking to each other or that is not able to consume what has been produced in a silo. I'm going to say when a silo, I'm talking about the technology silo. So you have a group of people, and this is where I invite you. If you are the analyst, if you are the SME, if you are the data engineer, or if you are the data scientist, I invite you to read the boxes that are not yours. Think outside your own box. Think outside your own box. Who needs to be able to do something with this model outside my own organization? But beyond that, how do we plug in into a framework that is going to allow us to operationalize what we are doing with machine learning? That is going to allow us to scale what we are doing with machine learning. So when we think about our vision of, yes, these models are super common, now we have 5 in production, tomorrow we have 100, we are expecting to have 1,000 next year, everybody's going to ramp up and have knowledge on what's going on behind the scenes and so on. Everybody imagines the green line, but reality is more like the orange dotted line. Because these silos of technology, people, and processes, you have that friction, is not fully connected around. So where are we today? We are here because we know this has a promise. We know we are targeting use cases that we know are going to show value. So the promise of AI continues to be there. What are we trying to do? Anomaly detections, optimizing, increasing, reducing risk, better, 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 optimizing the flow at the end. But if I group what me as a engineer, consultant supporting this industry for the last decade, and everybody in the organization that we work for, talking to all of you and your peers around the world, across multiple use cases, across multiple verticals, we are still seeing the same main pitfalls. Number 1, data access quality issues. Here we go. Again, we are still trapped in the hamster wheel. We are still trying to connect to 5 data sources, create a join, and clean a table. And we are not even automating that. It's like, for real, why? Why is it so hard? Because the infrastructure continues to change. Because I was connecting to an on-prem, and now I'm connecting to an on-cloud. And now I have to do the join again. And I am not automizing that, so it's not part of an automation job. Or even worse, lack of operationalization and impact. I had my data scientists work all that phenomenal Python package and library. Now I have a TensorFlow anomaly detection. I'm ready for it. Good precision. I like it. Nobody else is using it. Why? It's in your computer. Who else is going to use that? How are you going to centralize those packages? Who is having access to that kernel? How are you going to operationalize that? How are you going to scale that? Number 3, lack of visibility and control. Had happened to you? You had the data scientist that knew Python, had a phenomenal Jupyter notebook, coded all those 3,000 lines of code, left the company. No documentation, nobody knows what's there. Somebody's going to try to define if that model has explainability or not. Where do we start? What is the visibility and control? That is going to produce very misused data experts and also frustrated. It's boring. I have questions on my data and I cannot see my basic 3 tables. Boring. So I'm going to look for something else to do if I cannot do my basic 3 things. Then you have the last one, which is costly and complex infrastructure. You have all those pockets of people working with on-prem, on-cloud, a little bit of here, a little bit of there, NLP, PDFs, NLPs, techniques, all of that, and siloed in that complex infrastructure. So as I said, I use AI to generate these visuals, and I actually think they are very, very powerful. I invite you to think I'm going to show you 3 colors. These are going to be the green boxes. We're going to talk about the blue boxes, and we're going to talk about the purple boxes. Think about in which box you are today. These are the green boxes. Who are these guys thinking? Okay, I work on this machine learning model. I put all of this effort into this data product. Call it machine learning model, dashboard, data table, data product. It's my baby. And now I have to hand it off. Who is going to do that with that? How do I hand over the project from one step to another one without being time-consuming? The second one, we have a lot of people. We mentioned collaboration, yeah. But you have people creating artifacts that are part of that pipeline in a way that doesn't talk or doesn't integrate with this other way. So you have pockets of artifacts that are part of a flow or a pipeline that don't talk to each other. Why? Super diverse infrastructure, tools all over, isolated. Or you can be the third one. Hey, how do we innovate without throwing away everything that we have been developing? And those are your data scientists that are thinking, I already created all of this code, use open source, use Python, use R, ensure that you make the most out of that community. Do not reinvent the wheel. There is no need for it. Use it, but use it in a way that can be plugged in into a framework that is ready for you to operationalize and to scale. Second one, that if you are not thinking about it today, you should be thinking about it. And we have been talking about quality of the data. We all know garbage in, garbage out. We all know that. What about AI quality? Do I know that the machine learning model is accurate, or do I care about that precision? Do I care if that model drifts? Do I care if I need to retrain the model because the data has been changing and I need to deploy something that I know is accurate and is within the standards of the company? It is within the alignments that we have internally on how to do things. How to automate delivery on quality of projects. Hey, how do we get the basics in an automation job? And when I say the basics, yes, I'm talking about connecting to a data source, do a join, and clean a table, done. Push that table down. We still have a lot of teams that are in what I call the hamster wheel. 80% of that is still there. And then you have the blue kind of boxes. And this is a group of people that perhaps is not you, it's not the data scientist that is creating the Python notebook, but you need to start thinking about how are you going to enforce those compliance? What are those regulations and policies that you need to keep an eye on it? And who needs to be sitting in that table when you are thinking about how you are going to have a framework to support the life cycle of a data product? Again, machine learning model, dashboard, table, call it. Okay, how to make sure our teams find and reuse the elements we trust. Why do we have to start from zero every single time that the platform changes? Can we just orchestrate on top what we need to orchestrate and make it future-proof? So if the underlying platform continues to change, which it will, I am okay, and I don't have to start from zero. I have reusable assets that actually talk to each other and are integrated enough from the technology perspective. And then you have a bigger picture that you have to consider. Who is deploying what? How many models do I have in production? How many of those models need to be retrained? How do I notify somebody if a model is drifting? How many ABC data products are part of my portfolio? And how I, as the bigger picture, are keeping an eye on it. Here we go. What's working? What is working in the industry? What it means to have a successful machine learning deployment for an enterprise environment. You're always going to have a very diverse infrastructure. So the unification of that orchestration, regardless of that change in the infrastructure, is fundamental. You be able to operationalize if you are part of this framework. And the framework is giving you at the same time the opportunity to provide feedback to that data product, and why not make it better? Ensure that the machine learning that you have deployed is actually accurate, following your standards. And repeat, repeat, repeat. Make the model better. Keep improving your data products, but know what's going on there. Understand what's going on there. I asked ChatGPT to summarize what are the main reasons for machine learning and AI projects to be unsuccessful in the enterprise deployments. Super consistent, not a surprise here. Data quality issues, we know that. Data garbage in, garbage out, no doubt. The lack of business objectives. What was the first thing that we mentioned has to lead the entire analytics life cycle? The business use case. That has to be first, no doubt. I have lack of expertise and resources. Why is that? Because it's very hard to reuse the assets that this very diverse group of people is creating. Coding, no coding, and all of that. And then you have that resilience to change. And Jim left, but we have talked about that many times. It's the cultural change required is one of the hardest things to provide over there. And then you have how we're going to consider this from the ethical perspective. Is this responsible AI? Is this model bias? Is this model showing results that we know are aligned with our own standards? So, what is working in machine learning deployments in enterprise environments? Collaboration. We have been saying it so many times, but I'm going to say it with a caveat. Collaboration with the opportunity to reuse assets that were created by you or by you, regardless if you are a Python lover or no. Number one. Number two, that SME, which is the subject matter expert, has to be part of that life cycle from the beginning. From the beginning. Sometimes we as a data scientist can be a little self-centered. And sometimes we don't care too much or underestimate the power of the insights from the SME and from the business. And that's a mistake, okay? That's an error. The sooner you involve that person in the life cycle, the better. And it has to be a constant part of that life cycle. High quality of data, we know that. We need to maintain that and keep it in. A stakeholder buy-in. Who is sponsoring your data product? And how that person is measuring success. What it means for that person to have a successful data project or product. And when I say data product, again, can be your machine learning model, or it can be the dashboard, or it can be the clean data table. What else is working? Reuse. Reuse. Eliminate the friction. Be able to collaborate, to talk to each other, but that includes the technology pockets. So being able to share a solution or an artifact that we create towards that life cycle becomes fundamental. Because you may have coding skills, I may not have coding skills, but as we saw, we are all part of the same framework, and we should be part of the same framework. So I'm going to invite you to think outside the box a little bit. And my tree on the right is representing all those coders that are part of that framework. And my horse on the left is representing the business users that not necessarily talk to each other, but this is for you to imagine what you can accomplish if you can reuse all of these artifacts that people, as us, is creating together. Like, why not to imagine that? And now imagine what you can do if you optimize the way that you are connecting your people, your technology, and your processes. And this is a very important slide right here. Think outside your box. Consider for the first time all the other boxes that are part of the framework. So the life cycle starts with the use case. Everything else is the ABC of data science. What is the ABC of data science? Connecting to ABC, transforming, enriching, creating my models, deploy it, keep an eye on it, ensure that what is being deployed is within my standards, and repeat. So if you are thinking about how to operationalize your models, what needs to happen in terms of that framework for that to be as optimal as possible, use your teams as they are today, not with the hope that you're going to have a PhD in a 3-month time window. That may not happen. And why not have your experts today that bring the know-how and the expertise on the field being empowered and being able to run their own machine learning models, because we are already living in the everyday AI chapter. This is available to the public. I mean, technology is here, and it's here to stay. And it's one button away to really generate a super cool deep learning model, literally. So how are you going to make the most out of that? How you're going to connect the dots within the framework from your own perspective, your own teams, and how that is going to look for you. So my Dataiku team, I know Nathan is in the back. Jason, raise your hand. Come and talk to us. If you have questions, come and talk to us. We are in booth 12. There is a lot that we can actually collaborate and work towards. And it's been a pleasure being here with you. I will say, if there are any questions, we have about 3 minutes. I can answer 3 minutes question. If your question is going to take more than 3 minutes, I invite you to have a coffee with me in the booth 12, Dataiku, the next room. Thank you so much.